Let's look at a two-sided hypothesis test for proportion using a TI-83 or TI-84. Here's the idea behind hypothesis testing. We have a hypothesis, which is a guess about what is true. We collect data to test the hypothesis. We plug the data into a formula and then use the result to determine whether or not our hypothesis is true. For example, I have a pair of 7-sided dice in my office. Are they fair dice? In other words, is every side equally likely? If the dice are fair dice, then the probability of a particular side coming up is 1/7. Here's the question. Is the probability of a 7, that is the probability of rolling a 7, is that equal to 1/7? That's not a 7, nor is that, nor is that. Oh, there it is. I rolled a 7. So again, here's the question. Is the probability of a 7, the probability of rolling a 7, is that equal to 1/7? I was curious. I have a pair of 7-sided dice. I rolled the pair 50 times a day for 200 days. That's 10,000 rolls of the pair of dice. It's like rolling one die 20,000 times. No joke. The result? 2,755 sevens out of 20,000 rolls. Now, expressed as a decimal, that's going to be 0.13775. Notice that 1/7 is 0.142857. Is that far enough from 1/7 to conclude that the probability of rolling a 7 is not equal to 1/7? Recall that the null hypothesis means no change, no difference, just what you'd expect. We represent that with an H0. The alternative hypothesis is that there is a change, there is a difference. We represent that with an H sub A or an H sub 1. In this case, H0, the probability of rolling a 7 is equal to 1/7. H sub A, the alternative hypothesis, is the probability of rolling a 7 is different from 1/7. Represented symbolically, let P equal the probability of a 7, that is the probability of rolling a 7. H0, the null hypothesis, P equals 1/7. H sub A, P does not equal 1/7. Here's how we can use a TI-83 or TI-84 to do this. So you choose Stat, press that button, and scroll over to Tests, and use one proportion z-test, because we have one proportion. We're not comparing two proportions, we're just comparing one proportion. Enter these data. P sub 0, that's the hypothesized proportion from the null hypothesis, 1/7. X is the number of successes, that's 2755. N is the total number of trials, that was 20,000. Here's the alternative hypothesis. The proportion does not equal P0. And then we just choose Calculate. Here's what we end up with. The p-value is 0.0390. What's the p-value? This is short for the probability value. It's the probability that we would get a result this extreme or even more extreme if the null hypothesis were true. Here the p-value is 0.0390. If the p-value is less than 0.05, where does that come from? That's just the default. If you're not told a particular level of significance, you just choose 0.05. So if the p-value is less than 0.05, which corresponds to a 95% confidence level because 1 minus 0.95 is 0.05. So if the p-value is less than 0.05, we reject the null hypothesis because there is less than a 5% chance that we would obtain a result this extreme or even more extreme if the null hypothesis were true. As textbook author Mario Triola puts it, if the p is low, the null must go. So if the p-value is less than 0.05, you reject the null hypothesis. Again, P, the probability of rolling 7. Here's our null hypothesis. Here's our alternative hypothesis. Since the p-value, 0.0390, is less than 0.05, we reject the null hypothesis and conclude that the probability of rolling a 7 is not 1/7.